Okay, ladies and gentlemen, dear colleagues, it's the last session. It's unbelievable how fast 2 days go by, isn't it? It's incredible. Yeah, the last panel is panel 6 about artificial intelligence and artificial life. And I thought that was a great topic to end this conference with, particularly about engineering life. And this morning when I thought about this panel, I kind of thought of a very well-known engineer whom you all know if you've ever watched Star Trek, the engineer Scotty, right? And there was one saying a few years ago that made it globally, even though this line had never been in this Enterprise, in this Star Trek series. And this sentence is, "Beam me up, Scotty, there's no intelligent life down here." And I'm sure that after this panel, we will know a lot about intelligent life, synthetic intelligent life, artificial intelligence, and we got some really great experts here, and I'm looking forward to this discussion. We have speakers from Germany and from Italy here, Kerstin Göpfrich, Monica Consolandi, and Mauro Dragoni. And we're going to start with a statement by Mauro Dragoni, who is a tenured research scientist at Fondazione Bruno Kessler in Trento, in Italy, where he's the head of Intelligent Digital Agents Research Group. He's also an adjunct professor of the University of Trento, and his main research topics concern knowledge management, information retrieval, and machine learning by focusing on the development of real-world prototypes as the outcome of his research activities. He received his PhD in computer science at the University of Milano. And he says that in recent years, conversational AI tools have become widely used in various settings, from customer service to personal assistance. And I'm sure everybody knows what that means if you've ever tried to give something back to a chat bot from Amazon. I did, and I failed. It's all yours, Mauro. Welcome.
Thank you. Thank you. Thank you very much for your kind introduction. So I have the unlucky role of participating to the last session, but I always like to see this as an opportunity because I can connect my topic with what has been already presented early in the conference. So we already seen in the previous session, we had a great definition of AI and its implication from the ethical perspective. And also yesterday in the presentation of Professor Palazzani, we had the introduction about different type of AI governance, like human in the loop, with which I would like to add also the concept of human out of the loop or human in command, that are all different types of governance that can manage the safe usage of AI systems from different perspectives. And then a point that attracted my attention yesterday, that was very inspiring, was the aspect related to the need of having different ethical guidelines for different technologies. That is a quite hard topic to discuss because it is directly connected with the thing that I want to bring to your attention today, that is the concept about human autonomy. So the aspect of autonomy has been already mentioned before, and I want to start by giving you a definition of human autonomy that is not mine, obviously, but it's been taken by a contribution of Karina Prunkel that has been published this summer, mentioning that human autonomy refers to the effective capacity of a person to act on the basis of beliefs, values, motivations, and reasons that are her own. So this is a very important aspect that is mentioned also within documents that have been published also by the European Commission, for example, the ethics guidelines of trustworthy artificial intelligence. It's a concept that has been highlighted also by the OECD Observatory of Artificial Intelligence in Europe, and that it is also contained in the Montreal Declaration about AI. So it is a very important aspect that, even if it is very important, it is a topic that has been hidden behind other ethical principles that instead are more famous, like the fairness of data. So we had a lot of contributions about how we can manage data in a fairness way, about explainable AI, so how to improve, to enhance the transparency of AI systems, and also to the aspect related to privacy. Okay, they are definitely more famous. And then, indeed, concerning the human autonomy, we don't have any structural guideline about how to implement, how to manage the human autonomy in artificial intelligence systems, because it is very hard to define if an AI-based solution is favoring or it has a detrimental effect on the human autonomy. So, which might be some examples of human autonomy? For example, when you are using recommendation systems, okay, you receive some suggestions about possible actions that you can do, from movies to diagnosis, so very wide different type of scenarios. But in this case, the risk that we have is that if the type of recommendations that are provided are not managed in an appropriate way, they reduce your autonomy in taking decisions. And while from the recommendation system perspective, this aspect has been already known from years, the recent new era of AI, so generative AI models like ChatGPT, and that is the most famous one, and also the other large language models, have this these ethical risks of reducing the human autonomy increased a lot. For example, before in the presentation of Luigi Repomonti, he said that also giving information, even if journalism doesn't want to do education, it is a sort of involuntary side effect of providing information, no? Because people trust information in a so high way that they make such information as a own personal knowledge. With the large language models, this risk increased a lot. But with the difference that if information are provided by humans that made research, verified sources, and also the other actions that are performed to give people information that are very reliable, this is not the same thing that is done by AI system, because the problems about which are the sources of information that support the generation of the text is still a known, very well-known big issue. So this obviously affects the human autonomy in different ways. And then, for concluding this introductory statement, I want to bring you the attention to the two most important human autonomy dimensions that lead to, in turn, the same to different challenges. The first one is that the aspect related to authenticity of the decisions of humans, because even if the decision of humans should rely on their beliefs, motivations, and reasons, at the same time, it is necessary to define a set of requirements that prohibit AI systems that any type of actions that, from the AI perspective, that can affect the autonomy of human of bringing decisions are included in this type of solutions. And then for this type of action, I mean any type of physical or psychological harm that AI systems can put in place, also not at a voluntary basis, obviously, but in any case can affect the autonomy of people of taking decisions. And the other one is related to the agency of the decision. So to be sure that humans always have the control about their autonomy of the decision that they made. What does it mean? It means that humans should always have all the plethora of options that they can rely on to take their decisions in a most informed way. So these are two challenges that are very open, very important, and that they can be considered as a very good connections about all the ethical aspects and then all the technological aspects of artificial intelligence. Thank you.
Thank you very much, Mauro. We'll come back to your introductory statement in a few moments. Our next speaker is Monica Consolandi. She is a researcher at the Fondazione Bruno Kessler in Trento and a consultant at the Pontifical Academy for Life here in Rome. She got her PhD in philosophy at the Vita Salute San Raffaele University in Milan, and is an expert in the emerging technologies and vulnerability in aged care and on ethical issues related to converging and emerging technologies. Now, Monica says, as new technologies rapidly integrate into various aspects of our life, including sensitive areas like healthcare, it is essential to reflect on their ethical foundations. Do emerging technologies uphold core ethical principles? Do they keep humanity at their center? And do they genuinely enhance human flourishing? Fascinating questions. We'll get answers. Monica.
So, good afternoon, everyone. You know, at this point, actually, the School of Rhetoric in the ancient Greece would suggest me to scream bad words to gain the attention of a tired audience. But I won't do that. And instead, I would just give you some insights to, you know, let's say, save our last energies to engage in a fruitful discussion. So Mauro Dragoni and I come from the same foundation of research, and you know, recently they changed their model that now says that the aim of our foundation that is very engaged with artificial intelligence research and to, you know, produce artificial intelligence, but also to research about it. Now the model is that the mission, our mission is to promote a human-centered AI. So my question is, what does actually mean to focus our attention and to be committed on human-centered AI? Because it's not actually obvious what we mean with this. And during these 2 very enriching days, I would say, we gain a lot of take-home messages that were really inspiring and teaches us a lot about human-centered research and human-centered AI in some way too, because we also talked about integrating ethics in our research. We talked about tailored ethics, especially Laura Palazzani talked about this, and ethics by design. So what do we mean about when we talk about ethics by design? What do we mean when we say that we have to integrate the ethics strictly and directly at the table of the research of new technologies and emerging technologies, and specifically ethical AI? So this basically means to keep at the center the human beings, but again, we talk about a lot of different perspectives. So we talk about education, saying that it's important to, let's say, train people about ethics in new technologies. We also talk about organizations, so tables of discussions and guidelines that have to be discussed and also teach it to the public. But there's also another level that actually it's not the most important, but for sure one of the most important, and it's the very basic level, we could say. It's the practical level. So when we do research, we can involve ethics at the table. And I'm actually proud to say that before human-centered AI became the motto of our foundation, we already did this in our unit. And I'm the one, let's say, in charge to deal with the ethical aspects of our research. And you don't have to imagine me just asking questions all the time to my colleagues about the ethical admissions of what we do. But instead, you have to kind of imagine a process that is itself ethical. So you have to imagine that ethics is integrated directly in the research process and so in the final outcome. And I'll give you just a very quick example. We have a project about the misunderstandings that used to occur in especially healthcare professionals and patients and families. The idea is to be able to understand which kind of misunderstanding occur, to categorize them, and also to understand when they occur more often, let's say, to teach AI to recognize them. And so you can clearly see that the process itself is intrinsically focused on human, because we don't start from the development of the AI tool, but instead we start from the healthcare professionals and patients and families interactions. So we are currently studying these interactions to understand this particular topic. And that would say that this can keep the human at the center in three main ways. The first is that because our studies must be in compliance with the regulations. So you can be sure that we are doing well here regarding data and data protection and patients' privacy and so on. So first of all, you don't have this kind of issue, let's say. Even though the final outcome is artificial intelligence, we start from human subject research. So we have to be compliant with regulations. The second is that in this way we produce reliable data. And this is not, you know, a second, I mean, it's a main point, because when you train AI, you want to have reliable data and certified data. And in this way, we can be sure that our data are safe and are reliable. And of course, the third point is also the first one, because in this way, we are sure that we are keeping at the center human beings in the process of our research and with the final outcome of our research, because in the final step is, let's say, a tool that can help both the poles of the relations to, let's say, prevent in some ways misunderstanding, and if it's not possible, at least to fix them. So of course, at first we have to train healthcare professionals and patients, as we said, is also about communication, is also about education. So this is for sure a part of our process. But a second part of our process is to build a tool that can help both the parts of the relations to improve their communication. So this was really a quick insight, and I'd be more than happy to engage further in the discussion if you have questions about it, but I would leave the rest of our talk to our discussion. So, thank you.
Thank you, Monika. Our next speaker is Kerstin Göpfrich from Heidelberg. She's professor at the Center for Molecular Biology of Heidelberg University, and until 2024, also an independent Max Planck research group leader. She received her PhD in physics in the UK at the University of Cambridge, and we've met each other a couple of times over the past years and started to work together, also together with her team, in our ethics project, Art of Molecules. So we got to know each other quite well, and I'm excited that you and members of your team are here today. Kerstin says the emerging field of bottom-up synthetic biology has made progress towards constructing a cell from molecular parts. Our vision is to create a simple model of a cell that consists of a lipid vesicle and operates based on our own custom engineered and genetically encoded molecular hardware made from DNA and RNA nanotechnology. And one wonderful quote I found, another one is, "I have always been curious about fundamental questions in science and long fascinated by the idea to engineer a cell from scratch." And when we were in Heidelberg, I said, but why? Isn't biological life complicated enough? But I learned she has good reasons. Monika, welcome.
Yeah, so thanks very much, Ralph, for the introduction. Yeah, we'll move away a little bit from AI. So I think the discussion, we can merge the two fields again. But for now, we'll move away from AI, and I'll invite you to think about or to imagine that we could create a cell from scratch, from molecular building blocks. But before I dive into the science, I would like to highlight that science is teamwork. And I would like to acknowledge the most amazing team that one can imagine. Eric, some of you may have met, he is around. And yeah, it's all their work. It's really amazing to work with such a team. Yeah, with this, I would like to come back to the scientific question that has really captivated us, and not just us, I guess humanity, for decades and centuries. And it's the question whether it is possible to create synthetic life in the lab. And I will ask this question to you in a moment. I would like to hear your opinions. But first we need definitions, right? So what is life? What is synthetic? And what does it mean to create? Right? We talked about definitions of life earlier. For me, life as a physicist is a state of thermodynamic non-equilibrium. So it's about constant chemical turnover, about an active system, because if you stop being active, that means death, right? Now, what is synthetic? Well, I guess synthetic is everything that's not natural, right? And natural is, I guess, everything that follows the laws of nature. But I guess a synthetic cell or a synthetic life should do that too, right? So it's complicated. Now, what does it mean to create? Well, Feynman, a very famous physicist, once said, what I cannot create, I do not understand. Right? So the creation is a really fundamental part of the scientific process. Now, is it enough when you're creating? Is it enough to tinker with a system? Or do you actually really have to create something from scratch, right? Now, and this brings us to really the heart of synthetic biology, where we see these two opposing streams, namely top-down synthetic biology and bottom-up synthetic biology. In the top-down approach, we'd start with a cell, we'd manipulate it by tools like genetic engineering to arrive at a synthetic cell which has desired properties. For instance, it can produce a value-added product or so. Now, in bottom-up synthetic biology, we think a little bit more fundamental. We literally start with single molecules, with building blocks of life, and we try and piece them together like the pieces of a puzzle to build a cell from non-living components, from non-living building blocks. So if you come back to the question from the beginning, is it possible to create synthetic life in the lab? We realize that we have to specify this question or formulate it in a more precise way. So is it possible to create a living cell from a priori non-living molecular building blocks? This is what I should have asked at the beginning. And this is what we are after, at least. So I would like to ask the people in the room, who of you thinks it's possible to create a living cell from non-living building blocks? Who of you thinks it's impossible? Okay, I would really like to see the divide here between scientists and those that identify more with the ethics stream, but my guess would be that it's almost similar, because we always get, no matter what community I ask, it always seems to be like 90% of people are positive and believe it's actually feasible, and about 10% are in doubt. And I have to say, I can sort of understand both views, because to give you my opinion is, I don't think it's possible to actually engineer a very complex cell from scratch, but I think it's possible to engineer something very simple and then to harness the power of evolution to enable it to perform more complex tasks. And this is why the goal of my lab has to become to bottom up engineer a very simple synthetic model cell, which is just about capable to self-sustain and evolve with our own molecular machinery that we want to engineer from scratch. Now, so this is what we are after. Now you can still ask, is this possible, right? Ideally, we want to engineer a good cell that does good things, like this cell that you see over here. It's a white blood cell that works on our behalf, chasing a bacterium, right? So ideally, we'd like to get to something as complex as this. Now, the complexity of life as we know it may raise doubts about the feasibility of this endeavor, of course, because we know that every cell that we find on Earth today emerges from a pre-existing cell by cell division, right? Now, there is one example in the history of life on Earth, namely the origins of life, where life must have emerged from matter. Now, is it possible does this allow us to conclude that this is possible to do this in the lab? I don't know. But we know that we were at a similar point before the rise of organic synthetic chemistry, where a large fraction of scientists believe that it's not actually possible to make organic molecules by synthesis in a laboratory, but that they have to be produced by animals, for example, right? And this was until urea was synthesized, and we had a first proof of principle that in fact, by chemical synthesis, you can produce organic molecules, and this gave rise to the field organic synthetic chemistry. And I believe that in synthetic biology, we are currently at a similar point where a proof of principle is needed, that we can actually build a synthetic cell, and then we can go from there and evolve it, hopefully, towards more complex but also more meaningful tasks, like the cell you see over here. So how would you start? It's hard, right? How would you engineer a cell? Well, we know how to solve other kinds of engineering problems, right? I lived in the UK for a long time, so people like this device a lot. So if you wanted to engineer a toaster like this, you may want to take it apart, you may want to look at the pieces, you may want to identify the ones that are very important for its functions, and you may try and piece them back together to build a functional toaster. You can read up on this endeavor in this book over here, The Toaster Project. Now, if we want to engineer a cell, we can take a similar approach, right? We could start with a living cell. We could extract some components. We could we could smash it into pieces, basically. We could extract very important components for a given function, and then we could boot them or check for their function on the inside of a lipid vesicle, right? But then you quickly realize that in order to construct life, you need many more components than this. So the problem becomes very complex very, very quickly. And you also realize that those components that fulfill function are oftentimes proteins, and proteins, unfortunately, cannot copy themselves. So you need the whole transcription translation machinery, which in and of itself is about 150 genes. So what do we do? Well, instead of recombining the pieces of the puzzle, you can ask yourself, is it possible to use new tools and new materials to arrive at something which has the same functionality? And in our lab, we've settled on DNA and RNA origami because DNA and RNA are in principle molecules which have the inherent capacity to copy themselves. And with origami, we can give them a lot of interesting functionality to make folds that are more than just information, so to say. Now, what is DNA origami? Well, we all know DNA as this spiral staircase-shaped molecule that stores the information of life. Now, if we unwrap this molecule, what you see is the genetic alphabet, the alphabet of life, so to say. And you see, when you read this alphabet, then you see that A always pairs with T and G always pairs with C, right? And this information we can use to build with DNA. So imagine we take a piece of this spiral staircase, unwind it, we extend single-stranded arms, so to say, then we create a binding site for a third piece of DNA, and we can create a star from DNA. So simply by controlling the sequence, you can start from something that is a double helix, extend a single strand, create a third strand which binds by this complementary base pairing, by this fundamental rule of life, and then you create these kind of nanostars. With many strands of DNA, you can really make complex shapes and give them complex function, at least if you add chemical modifications to these strands. So, in fact, it wouldn't be hard to make a crane like this. Could be done within a day in the lab. You simply make a drawing on the computer calculates the DNA sequences you need, you mix them up, and you would get any nanoscale shape of your desire, so to say. And like this, we've been building functional components for synthetic cells that fulfill different kinds of functionality, but we have been building them, right? So now, in a living system, what you'd like to have the synthetic cell build its own molecular machinery. So recently, we turned towards RNA origami, where we basically started to design synthetic genes which encode not for a protein, but actually for an RNA nanostructure. So we design a synthetic gene in DNA, we add the natural enzyme, so that's the RNA polymerase to read off the DNA just like it would do inside of a living cell. And as it reads off the DNA, it produces an RNA strand, which because of the genomic content of this DNA strand, it can fold up in the desired manner. So we constantly feed with the nucleotides, the fundamental building blocks of life, to create nanostructures as we go, so to say. And these nanostructures, they can have added functionality beyond the normal RNA, so to say, by making use of, for instance, aptamers, which are RNA sequences that bind defined molecular targets, or ribozymes, which are catalytically active structures that can catalyze chemical reactions. And like this, we can piece together different building blocks, assemble larger units, like this one, which is meant to mimic a cytoskeleton inside of a cell. Now, here you see the family portrait of our synthetic cells that we've built so far, so to say. They contain oftentimes DNA origami, and they have distinct functionalities, like for instance, they can divide, they have a kind of artificial cytoskeletons, or we've made DNA origami structures which control the shape of these synthetic cells. Now, if we now start to genetically encode all of these structures in RNA origami, we arrive at a system where we can introduce mutations on the DNA level, small alterations in the genome, which then result in different functionalities, so we can start to evolve these synthetic cells. And now imagine we could genetically encode this division process and then evolve for better division, evolve for better synthetic cells, and one day evolve for good synthetic cells that do good things, so to say, as I showed you in the video in the beginning. So that could really, I think, revolutionize the way we manufacture at the moment. This should be accompanied by appropriate ethical considerations, which I'm very much looking forward to discuss with you, and we are not there yet, right? But what I can tell you is that the components that we've been building for synthetic cells can already be used right now. And I'm illustrating this here with a few examples. So this DNA origami smiley, which we printed inside of a lipid vesicle for no particular reason, resulted in a methodology to basically release morphogens, so molecules which guide the differentiation of organoids inside living organoids, as you can see down here. So that's a nice tool, so they become tools. Now, just like the 3D printing over here, we 3D laser print inside of lipid vesicles, which became an image-based sorting technology. We were working on a method for dividing synthetic cells and realized that this could be used for osmolarity sensing, so sensing the number of particles in solution, which was not possible before with live cell microscopy experiments. And these are just examples. If you follow a Blue Skies research question, you inevitably stumble across technologies. And this, for me, is an important justification of doing Blue Skies research, that it brings about solutions that you may not even have thought about beforehand. And I want to really conclude with this plea for Blue Skies research, and also invite you to think about the question, or invite you to imagine we could build a cell. With this, thank you very much.
Thank you very much, Kerstin, for this interesting talk. Well, panel is ready to receive and answer your questions. Yes, hold on, please. We have a microphone there. Thank you.
Okay, my question is to the last speaker. So let's imagine that you're successful in creating these synthetic cells. They divide. They divide, they develop. At what point do you think that in order for this to be safe, we should develop not antibiotics, but anti-synthetics?
Well, so is a very important question, right? We do have to think about the ethics. We earlier talked about, synthesis of synthetic viruses, right? With SciReady, for instance, right? So it is a very important point. And in the end, what we do is, in a way, gain of function research, right? We're trying to evolve something to obtain more complex functionality. And maybe as a first step, where we should start is to define a point where biosafety regulations that we already have in place, that already apply to genetically modified organisms, for instance, should also be applied to synthetic life, right? And I think this point is reached in the moment these things can self-replicate and evolve, right? Once this is achieved, we simply have to put in place the biocontainment laws that are that we already have. And what's needed beyond that is something that I would really like to ask the room. What do you think is needed beyond?
Nick, please.
So at the start of the meeting, I gave a talk on feelings and their emergence from living cells, really, from the metabolism. So I argued that feelings are kind of grounded in metabolism, and that they give rise to higher forms of consciousness ultimately, and also to morality grounded in things like suffering and pain and so on, so of real importance. Now, both artificial intelligence and artificial life are potentially going to be very, very different systems, and therefore would not have, when taken much further than you've been talking about, would not have a morality perhaps in any way that we would recognize, and so any ethical regulation perhaps would also necessarily be very different. Is it far too early to worry about these things? Is it not relevant at all? Or should we start to be thinking about the morality and the ethics of artificial life?
Thanks for connecting the panel.
Please.
I think it's never too early to think about that. But actually, I think it also really depends on who is doing research on this topic and on these tools. We know that for sure there are industries and companies that are not really into that. But at the same time, we know for sure that there are maybe smaller companies that are really committed to, let's say, supervise all the process to be sure that the final outcome is ethically admissible. And I think if we keep working in this way, we can be, let's say, not sure, of course, because we don't know, but at least more relaxed than what we can imagine about artificial intelligence. Because as far as I see, the processes are structured and properly supervised in these terms. Especially, I'm thinking about the healthcare context, of course. There is a very sensitive one. But we'll see. You know, the evolution is very quick and quicker than expected. And so for many reasons, it's very difficult to foresee what will happen.
Mm-hmm. So, thanks for the questions. Very, very interesting. I think that it's not a point about be worried about that. It's just I would like to consider that for example, the advent of generative AI that changed the paradigm, changed our perception of AI, because started to be more invasive, more pervasive in our life. I think that instead of being worried about that, we should increase our awareness about what artificial intelligence now can do for ourselves or can impact in general on our lives. Okay, because in the last couple of years we observed about how the way with which AI can impact on our lives changed a lot. So increasing the awareness means that in a genuine way we can start to observe what it can do, how it can impact, and then to start to design some regulations about how it can be used in order to preserve the principles, the ethical principles about, for example, self-harmness, okay, that before generative AI was taken more under control because the advancement of artificial intelligence were not so far that can affect this principle so much. So increasing the awareness and then work on in a genuine way about defining new regulations when necessary in different domains, because different domains means that different regulations are necessary.
Yes, please.
I have a question and a comment. Yes, we are already widely using artificial intelligence in surgery for many reasons. We have all the robotic system working since a long time. But a general question that arises is the artificial intelligence depends from the information that they have. And then the reliability of the information is something, the critical problem. Because in the evolution of medicine, we were fighting against our certitude for the incertitude. And we found new therapies, new diagnoses, new development. They are all coming from the fact that we are overcoming the certitude at the time with another question rising in the mind of a certain individual, which was looking what to do and what they were. The invention of antibiotics, the discovery was an hazard. And the hazard is not so much included in the artificial intelligence organization. Then I put the question, can this represent, in one side also, a possible limit to the evolution of medical science?
Yeah, that's why I very briefly mentioned certified data, because for sure that it's the basis of for a reliable tool. But I don't think this is the limit of artificial intelligence. I think the opposite. So it's really a matter of time to build tools that are more able to, more and more precise, and that have a broader knowledge about the world, and also there are possibly less bias, because we want to broaden the data that we use. And of course, it's not only a matter of time, because it's also a matter of how we structure this tool, of course. But since I see that there's a strong common effort to do, to go in the right way, I'm pretty sure that we will do this. Also because, if you want to integrate, also because I think in the end it's counterproductive to have a tool that is not built on certified data. In the end, the answer that it will give to us would be useless at this point.
Thank you. And I'm sorry if I take time. Another question. We do medicine for the beneficence principle. Medicine is done to help the disease, to help the people to face the diseases. And then the problem is that one. Did you believe that in the world, my decision to go to medicine, which is a private decision inside my family, and knowing that I will face also to an artificial intelligence who can once ask me if what have any distraction when I was looking at that patient and thinking that this patient can have this kind of disease, instead that 0.3% possibility that she can have another one, which is also present in the exam. But humans are fragile, and sometimes when we make our decision, when we make our interpretation of that, we have some distraction. Did you believe that this possibility can modify the normal attitude to become a doctor in our daily life?
I try to answer to your question. I want to add a bit, before answering to the previous question that you made concerning the aspect of hazard, being hazard. I think that the concept of hazard for humans is also connected with the concept of intuition, or human intuition. That is something that in artificial intelligence right now, today, cannot be replicated. And my personal opinion is that we are quite far from being replicated, because how much our human intuition is an hazard or not, okay? Because our intuition probably is became from our certainties that are created from experiences or from other things that characterize us as humans. Okay, I think that the impact of AI, from the second question, from the last question that you make, AI can impact on human behaviors, also in the medicine, of becoming a doctor, or acting as a doctor in a certain way, because obviously now also physicians cannot ignore the levels, the quality, the effectiveness of AI systems, but obviously that they can support them because they are able, for example, to give you the last updates of the last clinical trials that have been updated yesterday on both American and European portals, and that that physicians, for the time that they have, because they also have to care patients, cannot go in the details about each clinical trial that has been uploaded and approved. So all this information through the use of an AI system can become a great support for the work of physician, but obviously to put always, the last decision at the human level. Okay, so I guess that the next generation of physicians should focus on how to exploit the capabilities of AI as much as possible in the most effective and efficient way, but obviously to consider it always as a support and not as a sort of oracle for having the last word about diagnosis, obviously. This is my personal opinion.
Can I comment? Not at all as an expert, more as based on feelings. So I feel like a lot of us have already kind of lived through a similar transition when maybe Googling became, or use of internet became kind of the standard, right? Before all of the physicians have been looking through the books, and this was a set of knowledge that was written down, was there, right? And then all of a sudden there were many sources of information. There was the internet, you had to filter and so on, right? So I wonder, I know it's something completely different, and it's a revolution for sure, right? But I wonder, if we can maybe learn a bit from this and also see it through those eyes that, it's a revolution, but it's not something that we haven't seen in the past.
Yes, please.
Hi, thanks. Sorry. Thanks for the talk. I know, Kirsten, you posed the question to us, is synthetic life possible? But I actually want to pose the question to the panel now. Do you think artificial life is possible? And I was just wondering, actually, what do you think? Because there are a lot of questions that have kind of analogs in that field, like what does life look like in an artificial system, right? And I was just wondering if to have actually all of your takes on this question, and what actually is there anything that one community can learn from the other when dealing with this, also in terms of an ethical standpoint, safety standpoint? Thanks.
Please.
So maybe we have to also for the room and maybe also for us clarify a bit the definitions here, right? So oftentimes the term artificial life is used to describe form of lives that aren't necessarily biochemistry, but they can also be life in a computer, so to say, or in a computer-based system, or a synthetic life usually describes a biochemical system, right? Even though sometimes I've heard the use of the term artificial life being used when synthetic cells are really based on artificial building blocks. So I guess we have to differentiate here a little bit. But so I would say, to give you my take and then pass on, I would say that what's really cool is to really see the convergence of those fields. So maybe synthetic life and artificial life, or something that happens based on an AI in a computer system, so to say, can cross-fertilize one another. So the way I see it, for instance, in our systems is that, there is an infinite evolutionary landscape. So can AI help us explore part of it so that our experiments can then only explore a smaller part, a subset of that, right? So that basically AI informs the experiment and vice versa. So we'll really have an artificial synthetic life that combines the best of both worlds, so to say.
Okay, Kevin?
No.
Or do you want to?
You get
Very quickly, no, I come back to the topic of physician and artificial intelligence, because I think that we need to address the topic from the perspective of liability, because
I think that we are going to have a new kind of defensive medicine, because for the physician, perhaps in the future could be easier to follow the indication of artificial intelligence, even when artificial intelligence must be a co-pilot, not a pilot. But for the physician, imagine my opinion, my we call in Spanish ojo clínico, my experience against this big machine, which is considered by everybody the new power of knowledge. I think we need to consider this, because if not, we are going to have this kind of defensive medicine against the patient, maleficence system based on artificial intelligence. And this is a huge topic, I think, for the future, because the legal system usually will be based more on the opinion of artificial intelligence, strong opinion, and not on the weak, good opinion for the patient of the physician. And this is a problem.
Well, not as far as AI is a support, like a supportive tool for physicians. Also, I think that when you learn how AI is built, you don't worry actually that much about the fact that it could be autonomous. Of course, it depends, again, on the way you develop AI, but since we're talking about a very sensitive context, that is the healthcare one, and this, I would say, protect. So it's a protect environment, and we're very committed to protect patients, but also, and their families, but also healthcare professionals. I think this is not a scenario. And also, and in part, I'm answering also to the previous question. I don't think that artificial intelligence could become artificial life as far as it's controlled by human beings. I mean, working in the field, this is not a worry for me. On the opposite, as Mauro told us, AI could be a real strong supportive tool, also because, you know, physicians also make mistakes. So it could be on the opposite. Instead of a worry, it could be a real help.
We wanted to add, a comment as well about the last couple of questions. You mentioned the aspect of reliability of information. Obviously, on the one side, reliability is a must to create this type of information system, because of AI system, because now large language model use the entire web, with also all the things that are available on the web that we all knows. By assuming that we create effective AI systems based only on reliable information, then on the other side, also we mentioned before today, earlier today, the aspect of AI literacy. So to train AI users, okay, about what AI can actually do and how you must use it. So not to trust a lot, not give to the AI the role of pilot, but no more than co-pilot with their limits, okay? And to exploit all the benefits that this system can bring. This also connects a bit with the other question about if artificial life can be reached. I have a different perspective, also, obviously, for the other one, because probably when you think about artificial life and computer science, we always think about, Terminator Saga or something like that. Fortunately, we are still quite far from that. I think that it's not bad to use it as a sort of long-term goal for artificial intelligence on our side, but in order that by trying to reach that long-term goal, humans can benefit from the intermediate milestones, I guess. That it would be anyway important as well.
Kevin. So thank you again for the presentations, and these 2 days have been fantastic. So I hate to do this, but I'm going to bring up an issue that I think we haven't touched on yet that might sort of dampen some of our enthusiasm. I imagine that you might all remember 3 Mile Island, the reactor that melted down outside of Pittsburgh, and that Amazon wants to start it up again. Why? To provide energy for their AI. So AI doesn't just pop out of nowhere. right? AI requires a lot of energy. And the interesting thing in at least recent human history has been every time we come up with a new sort of central technology, industrial revolution, chemical revolution, nuclear revolution, we never take into consideration what the effect of that is going to be in terms of waste, in terms of energy needs and all that. And I think we're trying to start to learn that lesson. So thinking of all the things we want to do, all the blue sky we want to pursue, that has brought about a lot of these things, how do we now take the responsibility position and say, can we do all this? And if we do, ethically, how do we justify it?
So if I can start to answer to this now, it's a very good point, because I mean, I didn't touch the ethical aspect from the green perspective, because obviously we live in this planet and we are affected about, I mean, the pollution that we create. The AI, I mean, is not affected by that. The thing that as researchers we do concerning this topic is try to foster the adoption, the design and development of not what are the antagonists of large language models, so the small language model. That is, it is, I mean, it's not a joke, but it is actually real. Yes, it is a real research direction in our community, because first of all, it has been observed that also small language models can achieve very comparable performance from the effectiveness perspective. And then at the same time, they are more easy to be built. Okay, they can be tailored to specific scenarios. That is actually what we want, because it's definitely better to build small language models that can focus only on clinical diagnosis for a specific, for example, disease. Okay, instead of being something very big that is try to do everything. Okay, it's like humans. Everyone studies, I mean, focus on a specific topic, is not on everything, except some people on Facebook that try to be expert about everything. But it is something that we already do. For being effective, we focus only on topics, on research areas that we like and for which we think that we can give a contribution. So in AI can be done the same, and this can contribute on avoiding, okay, to be more green and more also ethical from this perspective as well.
Yeah, I think it's a matter of cost and benefits. So if we properly allocate resources instead of, having fun with ChatGPT, and we decide to regulate also artificial intelligence in this direction, it would be beneficial for the environment too. Of course, there's a price to pay. I agree, yeah.
I guess I share your worry. So the only thing I can say, and I don't even dare to say it because, I think one could easily be misquoted by journalists on that, is that in synthetic cell research, one focus direction is really also to drive synthetic cells for carbon capture and these kind of approaches. So like kind of synthetic chloroplasts and these kind of things. But of course, we are million miles away from anything that would make a big difference there.
Eric, over here. Do we have a microphone? Okay.
Kind of directly to follow up on that, I kind of got scooped to my question by Mauro here. But with the emergence of scaling laws in both large language models and in other related AI systems, it's clear that we haven't saturated either the number of parameters required to kind of express human expression, or we haven't found the amount of training data required to fully capture human expression. Medicine's a little bit more of a specific niche topic. It's still massive. But what are the pathways towards building smaller, more efficient models that are good for medicine? And what do the data sets, how much do we need? And what does the kind of architecture of the model look like? And how is it different from a general purpose large language model?
It is a very good point in this, also because around 48, I mean, two days ago, okay, there was a blog post in one of the specialized websites on AI that provided some insight about the performance of the last two big large language models that that was expected to be delivered from OpenAI, the Orion one, and then the new version of Gemini, that didn't achieve the improvement as they expected. No, obviously from this perspective, at a certain point, a sort of plateau of performance would be reached, because information available are not infinite, so we are limited in some way, and even if the architecture, so the technology about transformers, can be used for building different type of models, like the small scale language models, or foundation models in general, because we can integrate also multimodal information like images and other things. The idea is obviously that we should start to think about okay, there is a good technology, it is very effective, it demonstrated that it can definitely change the paradigm from many perspectives. Now it could be time to tailor it to specific scenarios in order to have this disruptive behavior on the common way with which we interact with the technological systems can be brought also into different domains in which we need to build something that can deeply support us to really advance also the quality of some services like healthcare, for example, but not obviously only on that. So I obviously agree with this point.
Mm-hmm. Okay, Mauro, you said the Terminator is some kind of possible long-distance endpoint.
For intelligence, not for what.
Yes. Kirsten, you mentioned using AI to improve synthetic life to the point where, at some point, maybe natural selection can take over, and so. Do we have any way of knowing, just once you've got synthetic life which is capable of reproducing itself and natural selection takes over, how quickly could we, do we have any idea at all how quickly that we may end up with the Terminator at that point?
Well, that's a very good question.
And definitely without morality.
Yeah, I mean, not just the Terminator, but ideally something useful, right? Even like a step below, maybe. It's an interesting one, right? Because evolution in the end is a random walk. So evolution goes without necessarily having a goal, right? And as a physicist, we know how much you can change a system if you turn a random walk into a directed walk, right? And I mean, what we do with our evolutionary algorithms or experimental systems is usually we'd aim for directed evolution. So we pose a certain selection pressure that we pick in order to select for synthetic cells which have a given desired functionality. Now, then you can ask, then I think the answer will very heavily depend on the exact question that you're asking, on the exact feature that you're trying to evolve. Anything from probably impossible on timescales of humanity to actually very much feasible on the scale of a PhD project, right? And I think we simply have to start with those things that are very much feasible in the scale of a PhD project, like for instance, in our case, improving our RNA-based molecular machinery for synthetic cells towards a specific goal, and then go towards more and more complex things that we would really like to do, or maybe also not like to do.
Yeah, also there's for sure a certain amount of unpredictability, as I said before, about this process. But instead of seeing this as a problem, I would see it in a positive way. Not because I'm naive, but probably because I believe in what we do. So I think we will be surprised by the future and by, let's say, our creativity. So I will be a bit positive, to end all of these 2 days that were more about worries.
I'm not trying to be negative. I'm just curious to know what your response is.
I know.
Also because if we want, we can try to teach morality to AI systems as well. or at least it is possible to do that.
it's also possible to have a very potent directed evolution from bad actors who are human.
Done so well teaching human.
Yes. You know, 2 years ago, I remember quite vividly, we discussed intensively concepts, certain concepts, for example, the concept of personhood. And many of us thought we need to rethink these concepts because we are, in engineering, life sciences, starting to manipulate cells synthetically or with biological help. We're introducing new components. So what effects does that have on our concept of humanity, of components? And listening to the three of you, I think we also will have to rethink our concept of life. What do we mean by that concept? So perhaps the final question to all of you would be, do you think we need more regulation, more ethical guidance, or more interdisciplinary discourse? Of course, it will be hard to say no in a conference like this, but to kind of guide you all as researchers and introduce society in this process.
Yes, but I won't regulate everything, because otherwise it would be, you know, too structured and static. We need something that is also dynamic.
Yes.
More regulation, I'd say not necessarily. More exchange and discussions like this. I think the past has taught us very, very strongly that we should integrate science and ethics very early on. Yeah. Definitely.
Mauro?
Yeah, I think that, I mean, before reaching new regulations, probably we could have new guidelines for creating awareness, not only researchers, but also in people, because they are all the actors that will benefit from technologies.
Kerstin Göpprich, Monica Consolandi, Mauro Dragoni, thank you for this fascinating talk.